what is this cloud computing? Instead of having this physical machine with you here, you can create, or rather access most of these resources on demand access, and they use pay as you go model. So pay as you go means the more the resources you are accessing, that's the amount you'll be billed or you will be paying. Ideally, most companies currently, they are trying to leverage using cloud technologies to store the information. Most of the pictures you upload there, where are they being stored? That is now the power of cloud. We have Amazon, which now offer under AWS, which is Amazon Web Services. They offer cloud solutions. And then we have GCP. GCP is Google Cloud Platform. And then we have Microsoft Azure and many more. We partnered with Amazon, so we train most of their certifications program. Those certifications are, we have entry level or rather foundational, associate to professional level. So you can enroll into either of the certifications so that now you start your journey to the cloud. If you are a developer, it becomes much easier for you now to build your products on the cloud and make sure that they are easily available.
Ladies and gentlemen, today will be a more of like an introductory to AWS and services, and what are some of the things that you can do with AWS. Some of the things that I'm going to talk about might be, or you might use them in the near future, or you can come back to Zalego and ask for some information about training. So we are going to start off by an introduction to cloud computing. And this is an awareness, trying to discover what is AWS, what are the services that we offer, and what are some of the sessions you can do, trainings, and who are the trainers, training institutions that you can use. For now, for the next 1 hour, I'll go through a couple of things, through a couple of slides, and I will have 10 minutes or 15 minutes break based by the moderator, who is our Alex here. Then we're going to do to see after every hour we do a break for a minute or two so that we can stretch up a bit. Then we continue with the content. So today we'll be talking about introduction to the cloud, and to be specific, AWS. The reason why we are doing AWS is because out there are so many cloud vendors or cloud computing vendors, but specifically today we are dealing with AWS. And what we're going to discuss in this module is that we're going to define what is cloud and how it works, and start now exploring what are the benefits that we can get from AWS Cloud or Amazon Web Services. But before we jump into AWS or Amazon Web Services, let's first of all understand what we have currently. In many of our institutions, we determine our load by what we are expecting. If we're having a product that we are launching probably in a week's time, your IT department usually is very busy because they want to know what will be the maximum peak, or when is the maximum peak, or what kind of resources do we need, or what kind of storage do we need. And the question is, after that, what do we use resources for? So we might end up at the end of the day reducing or having that those resources lying somewhere idle. But then when you talk about cloud now, this is when we start discussing ourselves. What is cloud computing? Cloud computing, by definition, is the on-demand delivery of IT resources over the internet through a pay-as-you-go model. Now, that statement carries a lot of words. It's the on-demand delivery of IT resources over the internet through a pay-as-you-go model. So, on-demand delivery is that in a normal situation in your organizations, you'll find that if you want to buy a laptop, there are so many processes that you have to pass through. You have to pass through your direct reportee, managers, finance, logistics. By the time the laptop is getting to you or any other equipment, it can last almost a week. But in AWS, we get what we request for it, we get it immediately. And we don't invest in large upfront investments. Meaning, if you're having an application that you're coming, we cannot buy resources right now to use them later. We only provision for what we require. If we need, let's say, a 20 GB machine, that is what server, that's what we're going to get. And lastly, we pay for what we use. If we buy a server right now, a physical server, you put it in your data center or you put it in your office, whether you are using it or not using it, it will require internet, power, or other maintenance. But when you deal with AWS, you only pay for what you use. If you're not using it, you're not going to pay for it. But what is this pay for what you use? So going in depth in talking about pay what you use does not mean that if you launch a server, for instance, if someone and you deploy your application inside that server, doesn't necessarily mean that if no one is accessing your application, that's when you don't pay. It means that as long as that service that you're using is running, that's when you're going to pay. If the service is stopped, then you're not going to pay for it. And what are these components or what are these resources can we get from cloud? With cloud computing, we can get servers, storage, databases, application, networking. So some of these are the core components when dealing with cloud computing. But do I really need to move everything to cloud? Is it a must that you can have everything in cloud? Different organizations, different developers or different solutions architects have different ways of deployments. We're going to look at three main ways of deployment when you talk about cloud computing. The first one is cloud. And cloud, this is where now everything is being done in the cloud. Whether you are starting your new application, whether you are starting, you're deploying a new server, everything is done in cloud. I'll jump hybrid for a second, and I go to on-premise. Now, on-premise, this is the physical data center. Whether you're having a small server room inside your office or is a huge server room that you're having in your office, that we call it an on-premise. And popularly, we're going to refer to this on-premise as a hybrid deployment. Sorry, as a private cloud. On-premise are also referred to as private cloud. Now, when you combine a cloud deployment and an on-premise deployment, you get a hybrid deployment. Later in the course, we're going to see what are the components do I need so that I can come up with a hybrid deployment where a part of my application is running on-premise and part of that application and part of the application is running in on-premise. It can be that since your data is so sensitive that you cannot put it in cloud. So your database is on-premise, but then the application itself is running in servers in cloud. So how then do you create that connectivity between your on-premise and on cloud? We are going to see that later on. So why do I need, if I can use on-premise or if I can use a hybrid, what are the benefits will I gain by moving to cloud? There are four main categories there are four main benefits, but they are more. that you can gain when dealing with dealing with AWS. One is agility. Now, sorry. We talk about speed and agility. Remember, earlier on, we talked about getting on-demand resources. We request, we get it. So it is very fast for developers to get a server rather than requesting for a physical server. This makes the pushing out of your deployment, make it faster. Two is agility, where you can make mistake. You can make so many mistakes over and over again without necessarily minding what you're doing. And a good example would be if your application is running on a Windows server and you need to run it on top of my Microsoft SQL server, SQL server. But mistakenly you run or you install, let's say, PostgreSQL, which is not compatible with your application, and you find that you do not have time to do all the configuration, and everything has been broken. So you can stop that instance, delete that server, and start a new one. So developers have that leniency of making mistakes and redeploying over and over again. With AWS, we do not need to, we do not require to keep on guessing on capacity. If we are having a new deployment or a new application that we are launching probably in the coming weeks, we cannot estimate the number of users who are going to use. With AWS, we talk about elasticity. And elasticity, this is where now we're saying, okay, when we can only add the number of servers based on the demand that is coming in. If the demand increases, then the number of servers that we're going to use or the number of resources you're going to use will increase automatically. When the demand goes down, then the number of resources will be automatically be removed. We are going to see those ones in a later date. So as I was saying, we have fast innovation. We don't have to wait for additional resources, and we are able to experiment and innovate more. And this is where we talk about you don't have to reinvent the wheel. Some of these resources are already there. You don't have to create them over again. Then we have elasticity, where if you want to have valid loads, increasing of resources, deploying of, when you talk about a fault tolerant, we're going to see that when dealing with scaling, we talk about what is fault tolerant and how we achieve that one in AWS. Then we have cost savings. In cost savings, we trade capital expense for variable expense. So this is where we talk about capex over or opex over capex. So we try to reduce, instead of us maintaining the entire data center in our data center, we reduce that by going to AWS and start paying for what we use. And when you talk about cost savings, through scalability, we are able to save cost by reducing the number of resources that we are that are not necessarily required. So by that, we reduce the content or the cost within our infrastructure. And then we have rapid deployment. Rapid deployment talk about highly available platform around the world, automated deployments, and quick release of new features. And when we talk about rapid deployment, this is where now we have CI/CD pipelines. If you're coming from development world, you already know what's CI/CD pipelines, where we are automating processes. You don't have to manually go in and do some of these three things. You can automate your processes. And we talk about scaling or highly scalable platform around the world. We need to understand, how is AWS globally infrastructured? What do we need for us to make sure we are running effectively and efficiently? So we talk about AWS global infrastructure. And AWS global infrastructure is made up of a couple of things. And we are going to look at those things one by one. I'll start with the top level one, which we call regions. And in this map that you are seeing is made up of regions. We have separate regions, and regions is a separate geographical location within the global footprint of AWS, where different services can connect to each other through a very high-speed connection with a very low latency. We're going to see that how we create all AWS regions and how they came about. Back here, if you see from what we only have one region in Africa called Cape Town, but some regions are coming up in different regions. Right, the other day we had the Dubai region that came in the other day, and some of these regions are coming up. So when a region, as I said earlier on, a region is a geographical region separated within multiple locations, isolated from each other. They are isolated by the fact that we need some fault isolation, elasticity, and also availability. Now, regions are made up of what we call availability zones. And availability zones, these are isolated portion of AWS global infrastructure. Within the availability zones, we have what we call the actual data centers, where these data centers, one or more data center, create an availability zone. Now, in a region, we can have two or more availability zones. Why do we need two or more availability zones? Remember earlier on, I talked about fault tolerant. And availability zones, they are designed for fault tolerant. And what is fault tolerant? Fault tolerance is the ability of your system to withstand a failure. It can be your server is not working, or it can be a network issue. So how is your system able to withstand such an infrastructure failure? Then the next one, another global resource is called an edge location or point of presence. Now, if I go back a little bit, you're going to see that in Kenya, specifically, we do not have a region, but what we have is a point of presence. Sorry, is a point of presence or an edge location. In an edge location, you do not store. Let's say you have your client. You have your clients in the United States or in Europe, for instance, but you are working in Kenya, or you have your clients in South Africa, and you're working in Kenya. To avoid high latency means the time they are requesting from one item to the other, you want to make sure it is very low so that you can have quick response time. That is the latency. So you need to put that content in somewhere closer to your customer. So the work of the edge locations is to provide caching services for your content. So they consist of what we call edge locations. And edge locations, they are used for caching services. So they make content available to the users way faster with high latency, sorry, with a very low latency at a very high speed. So in Kenya, we have an edge location that was launched, I think, in 2019. And then we have, I'm talking about something else that we have in Kenya, but we do not have a region in Kenya. We only have an edge location. So in a nutshell, what we can get from this is what are the benefits that we get when dealing with AWS. We talked about agility, elasticity, cost savings, and rapid deployment. To that for, do we have any question? Any question? So, and by the way, since we have a huge number of us, what we can do is that The question we're going to ask to answer, I'm going to answer the questions later in the course, because please, you have we have so many people. So when you ask your question, we'll have a Q&A session after the at the end of the session, so that we can save time in regards to the presentation for other presenters. So if you have any question, please shoot it on the chat. I'll come and answer it during the break times or during the Q&A session. So now that we've understood what are the benefits of using AWS, so we want to see some of these services that I talked about. I talked about some of the services that we offer. Some of the services that we offer, there will be servers, storage, databases, applications, networking. So I want to start now asking ourselves, so by this, how do we use those services and what are they? So I'm going to go to the next module, where we now ask ourselves, what are these services and what do we need and how do we access these services? And for those guys who may need for more information, kindly you can reach out to John or Alex, or go to our website. You'll be able to see all this information, or come into Zalego office at Divan Plaza Westlands. You'll be able to see to have more information. So in this module, we are going to ask ourselves or talk about the services. Okay, so I talked about servers. What are these servers? Servers will be referred to as compute, but the compute ones will be more of what are these compute services? What are these database services? What are these storage services? What are networking and content delivery? And lastly, we ask ourselves, how do we access these services? But before we continue, can we take a 5 minutes breather, please? Let's take a 5 minutes breather. So it is 2:31. So I'll be expecting by 2:36, we'll be back. Okay.
All right, thank you, Stephen. Thank you so much for that, and thank you for that initial presentation of the first module. As he has requested, please let's take a short break, and then when we come back, we'll introduce you to additional members of the Zalego Academy, specifically the principal, and then he will just share a few short words, and then Stephen will take over soon after that. But just a couple of minutes, please, and then we can resume this. Thank you so much.
Oh, thank you so much. So I'm made to understand that we have some of your colleagues. So please shoot your questions on the chat. We have my colleague Hashan and also Carol, who are already certified. So please shoot your question. They'll be able to answer your questions. Thank you so much for that, Hashan and Carol. Appreciate it. Thank you.
What is this cloud computing? Instead of having this physical machine with you here, you can create, or rather access, most of these resources on demand access, and they use pay-as-you-go model. So pay-as-you-go means the more the resources you are accessing, that's the amount you'll be billed or you will be paying. Ideally, most companies currently, they are trying to leverage using cloud technologies to store the information. Most of the pictures you upload there, where are they being stored? That is now the power of cloud. We have Amazon, which now offer under AWS, which is Amazon Web Services. They offer cloud solutions. And then we have GCP. GCP is Google Cloud Platform. And then we have Microsoft Azure and many more. We partnered with Amazon, so we train most of their certifications program. Those certifications are, we have entry level or rather foundational, associate to professional level. So you can enroll into either of the certifications so that now you start your journey to the cloud. if you are a developer, it becomes much easier for you now to build your products on the cloud and make sure that they are easily available.
Ladies and gentlemen, let's join back.
Yeah, thank you so much, Stephen, for that. And ladies and gentlemen, again, thank you so much for taking your afternoon off to come and join us on this AWS Discovery Days. In the initial introduction, I failed to introduce your host, who is actually our principal at Zalego Academy, and his name is John Juge. And I just wanted John to spend just a couple of minutes, let him speak to you about Zalego Academy, also as an AWS training partner, also speak to you about why cloud, and also just give you a very brief on career opportunities. So John, you have a couple of minutes to please just go through this, and then after that we hand it over to Stephen so that he can begin module 2. And then we can take it from there. And just a reminder, as Stephen said earlier, if you have any questions, please type them in the chat. We'll get to them definitely by the end of the session. And once again, thank you. And please, John, kindly join us and kindly say a few words and introduce yourself and the institution.
Thank you, Alex. Good afternoon, everyone. As Alex mentioned, my name is John, and the principal at Zalego Academy. And I'd like to thank everyone who's chosen to attend this event. We hope that this will be very enlightening for everyone. So first of all, I'd like to introduce Zalego Academy. For those of you who are attending our sessions for the first time, Zalego Academy is a ICT skills academy. We specialize in software development courses and cloud development and cloud courses, cloud architecture courses. So particularly for this session, we have invited you to get a brief introduction into AWS Cloud. So Zalego is an official ATP, and ATP meaning that we are an accredited training partner with Amazon Web Service. We got accredited early on this year, and we have been rolling out the program, and that's why we're doing these sessions. And we are accredited to do all Amazon Web Service courses, specifically the certification, professional certification courses, and foundational certification courses, and also professional and foundational. So we are here to actually get you on course or on track and get on the bandwagon, because cloud is the way to go. The benefits that you will derive out of taking these courses are beyond measure. Currently, the government is adopting AWS as the preferred cloud provider. AWS is also the leading cloud provider in the market globally, and the opportunities on AWS are immense. As you go through the course, and as Stephen takes you through the content, you get to learn also specifically the job opportunities available. But in Kenya recently, the adoption rate has been very high for AWS. The jobs that are being made available through cloud technology, specifically AWS, The opportunities are endless. So this is the time for you to join. This is the best time for you to get skilled on this, because currently the demand is very high. I don't want to take so much time so that we actually get into the core content. So later on in a different break, maybe we'll further expound on the benefits. But I'd like to thank everyone for choosing to attend today, and hope you enjoy the session. So let me give it back to Alex and Steve.
Stephen, the floor is yours.
Okay. Thank you so much, John, for that introduction. If you need more information, you can contact John. But for now, let me take one step back so that we can have a clean start. So we just explained, I did an introduction to AWS Cloud, seen some other services, some of the deployments that we can do. And we said some of the services that are offered by cloud computing are storage, servers, application, and databases, and so forth. But we want to have a quick overview of what are the services that we're going to offer, or a quick overview of the services that are offered by AWS. So here, we're going to look at compute, storage, database, networking, and content delivery. Remember, there's something I mentioned about content delivery, but I'm going to emphasize on it later. So lastly, we see how do we access these services. So we start off by talking about compute. Now, compute is a general word, does not necessarily mean that we're talking about computers. This is not computer, but it is compute, meaning is a collection of services. And some of these services that are under compute in Amazon Web Services, it's Elastic Compute Cloud, which people call it Amazon EC2 or an EC2 instance. And then we have Amazon EC2 autoscaling. And the reason why I'm insisting of Amazon EC2 autoscaling, because there's another autoscaling called autoscaling. Then we have Elastic Load Balancing, Elastic Container Service or ECS, and AWS Lambda. So I'm going to separate some of these into different categories. But let's start with our first one, the guy there called Amazon Elastic Compute Cloud or EC2. You'll see me saying an EC2 instance, but an Amazon EC2 or EC2 instance is a secure, sizable compute capacity that will enable you to launch servers in minutes. And to be precise, things are changing. Previously, we used to launch an EC2 instance in less than 5 minutes. That is for Linux or Ubuntu-based or Linux-based instances or EC2 instances. And Windows could take less than between 5 to 7 minutes to launch. So it makes it way easier and faster to launch an EC2 instance as you compare to the rest of the servers. Then with the EC2 instance, we are able to scale up and down. And what is this scale up and down? Remember, initially when I was talking about some of the benefits, I talked about elasticity. I talked about scaling, where when the demand increases, we are able to add services automatically. And when the demand is low, we are able to scale resources. Some of the resources is an EC2 instance. And the EC2 instance, we're able to add and remove as need be. And lastly, we have pricing options. And in the pricing options, we at the next level, we're going to see what are some of the pricing options that we can get. So just give me a second. Give me a second. Allow me to. Sorry, I see some hands is up. Sorry about that. So here. Okay. All right. So with the pricing options, we have a couple of. God. Is it my network or is everything's working? Am I audible?
You're very audible, Stephen.
Oh, okay. I thought I was not audible, so I was trying to reconnect.
No, no, no.
Sorry. Awesome, awesome. Thank you, Alex, for that confirmation. Thank you so much. I thought I was not audible. Anyways, so when it comes to pricing, we have different pricing options depending on how you're doing, and you're going to see that there are a couple of things that and a couple of activities or pricing options that we are going to have. And why do we have multiple pricing options? We want to make sure that at any given point you are able to minimize costs, running your resources right effectively, efficiently at a very low cost. Right. So it depends on the reason why the organization is moving to cloud. Some can be cost, some can be availability, and different reasons. One of it is always cost. You want to reduce the cost that you're using at your on-premise against what you want to use at AWS. The different options can be on-demand EC2 instances, or spot EC2 instances, or reserved EC2 instances. Now, remember when I gave a description of what is cloud computing, I said it is the on-demand delivery of IT resources over the internet through a pay-as-you-go model. Now, I want to look at that part of pay-as-you-go model, because here we are talking about multiple payment options. We have on-demand, spot instances, and sub instances. What are these? Now, when you talk about on-demand EC2 instances, this we are referring to when someone launch an EC2 instance. If they do not change anything, this is the default payment option. The default payment option is the on-demand. If you don't change anything. Now, how is the payment for the on-demand? You pay for the on-demand for per hour or per second. Now, Amazon Linux and Ubuntu, you pay per second, while any other operating system, that is Windows, CentOS, you pay per hour. When you come to spot EC2 instances, now previously, people used to bid. Bidding meaning, if let's say me and Alex, we are having Alex wants to use this server for $1. But I come and say, hey, you know what? I can use it for $1.5. So since I have a higher value, then AWS will give me the EC2 instance to use. Now, the only trick is if Alex comes back and say, you know what? Yes, I can use the same EC2 instance at $2. So that means AWS will say, okay, so and so has automatically your bid. So you have 2 minutes to remove your content from what you're using and use it somewhere else. But nowadays you request for a time period. Sorry. You pay for the time that you're using. But when your time elapses, you have exactly 2 minutes to remove your content. Then you have reserved instances. In the reserved instances, when you have your workload, that you know this workload may not change for a longer period, more than 6 or 7 months, then you can use reserved instances. And why spot instances and reserved instances? Because you get a huge discount when you use spot instances and reserved instances. So much discount. Now, with the reserved instances, you have a couple of methods, or sorry, a couple of options when you use reserved instances, and because you want to reduce costs. Okay, if for example, since we are using on demand, and in the on demand, you're saying you're paying, let's say $20 $20 per month. When you use reserved instance, you are going to get up to I think it should be 70, but I'll get the correct figure, up to 70% discount of the on demand. Okay, so with the spot and reserved instances, you get huge discounts for the two. So it makes your work you get your cost way down. But then we talked about earlier on, I talked about scaling in and scaling out. And we said, what do we need to scale in? So I mentioned about EC2 autoscaling. And EC2 autoscaling is a service that we use for dynamic or a combination of dynamic and predictive scaling. And between the two, dynamic and predictive scaling is, I'm going to start with dynamic. I'm starting down. What is autoscaling and talking about in terms of dynamic and predictive? Okay. We have our service that is running on AWS. Okay. But then it's hard for us to tell when there's a huge there's a huge customer request of our service, or there's a huge demand, there's a huge traffic coming in. It's very hard for us to tell. We can only tell by the fact that the system starts becoming slow. Okay. So by that, then we can start monitoring our server and our EC2 instance, and we say, okay, since we know that the server is always maxing out at this specific time of the day, so why don't we do this? Okay, on this specific, let's say it on Fridays at 2 p.m., our servers are always slow, meaning that at that point the traffic is huge. So what then do we need to do? So we can use dynamic scaling, where we say every time the CPU or the memory is at 70% or 50%, add additional server so that it can serve the traffic. But then what happens when the demand goes down? Let's say it's tomorrow in the morning and the traffic is very minimal. So what we can do, we can tell the EC2 autoscaling that when the demand goes down, please remove all the servers. I only need to run at least one server or at least two servers. That is dynamic scaling. And when you talk about predictive scaling, this is where we use machine learning to analyze past data. So we have to take the information from the server and you see how has the server been used? How has the server been utilized? So we use that information, past information, and we can say using predictive scaling that next week on Thursday at this specific time, this EC2 instance will be launched, and after specific time, it will be terminated without us necessarily doing anything. And what is the work of EC2 autoscaling? The work of the EC2 autoscaling is to maintain application availability. That's one, to maintain application availability. Another thing is, since it's doing application availability, we can still use it to maintain our low cost. By doing what? Because it adds and removes EC2 instances automatically based on our demand or the condition that we put place. The condition are probably the memory, if the memory is too high or the CPU is too high. So the main works of the EC2 instance is to add EC2 instances only when necessary. If it is not necessary, then it does not add. It does that by a defined conditions. Then we have, it removes unneeded EC2 instance when the traffic is low. This makes it this lowers our cost when automatically it removes an EC2 instance when the traffic is low. The fact that we are increasing EC2 instances and removing EC2 instances gives us that we're going to pay for what we use. If we are running 4 EC2 instances at this hour, we're going to pay for each and every EC2 instance that we're running. So meaning at the time that we have huge traffic, then there will be 4 EC2 instances running at one go. That means at that point we are going to pay for that. Now, since we have auto scaling, we do not require that when the traffic is low, we still have 4 EC2 instances. So really that EC2 auto scaling will remove 2 of those or 3 of those EC2 instances to remain with only 1 EC2 instances that we require, and we're going to pay for what we use. So an example is what I've just said, that I'm going to give a very good example in reference to on-premise. If we're having an on-premise and we are launching a new application, okay, we are launching a new application or a new software. So it's on Wednesday and the traffic is huge because we are launching our application today. So at this point, we buy new servers, additional resources to make sure that we are managing the current traffic. So how then, what happened the following day or the following week when the demand started going down? We'll find that we had bought huge resources, so many computers, but then the anticipated traffic did not happen, or it happened once and it never maintained to the resources that we had deployed for that. So we end up having wasted resources. But with the EC2 instance, that will never happen, because what we're going to do is, whenever there is an increase, we add an EC2 instance. Whenever there is a decrease, we remove an EC2 instance. It does so by what we call an autoscaling group. An autoscaling group has a minimum capacity, a maximum capacity, and the desired capacity. Now, a maximum capacity is when there is a huge traffic, there's a huge demand. How many EC2 instances do you want to accommodate that specific EC2 traffic? When there is no demand, how many EC2 instances do you want to run when there is no demand? But the application should be available. And when you talk about desired capacity, is when you start off your system, you start off your system by how many EC2 instances? Is like in the morning, if you go to a supermarket, you'll find that since the traffic is not, there are no people buying a lot of stuff in the early mornings, you only have one cashier. But the manager says, okay, since it's in the morning, we have very few people, then we can have at least two. Or if you go in the bank, okay, in the morning, there are always queues outside the bank. And therefore, the manager in the bank always makes sure that most of the counters have people. That means the first thing you do in the morning, how many people do you want to start with? The desired capacity. But the desired capacity cannot be less than the minimum. The minimum, it can be either greater or equal to the minimum. That when you scale out, you scale out when how many instances that you need. Okay, so we've scaled out. We started from one EC2 instance from our minimum, and then we have 4 EC2 instances. But how do we direct traffic into all those EC2 instances? How do we direct traffic into all those EC2 instances? Let's say if you go to Zalego.com, okay? Zalego.com is tied up to a specific EC2 instance, so it's to a specific IP address, which is constant. But here we have our application being served by 4 EC2 instances. So how then do we send traffic to all the EC2 instances? It's like in the morning, you go to your local supermarket, and you only have one cashier, and the queue is long. Okay, so meaning one cashier in the morning, and there's a huge queue. So what happened? We need someone or a supervisor or a manager to make sure that they are distributing this workload. If there is the morning and there's a huge queue, the supervisor will say, okay, cashier 2 can it open? Then you have someone else going into the cashier 2 to start serving the traffic. So that supervisor, we can call that supervisor a load balancer or an elastic load balancing, meaning they are automatically distributing traffic across multiple resources. It does so by the use of an algorithm called round robin. In a round robin, this is where you say, okay, I have 30 people in this session. For example, I had invited 100 people, but only 45 people showed up. But I have 100 gifts that I had bought for each and every person. So what happened to the 55 gifts that I had bought? So what I'm going to do is that I'm going to divide this gift equally among the 45 people who attended my session. But I have to make sure that I go the first round, each and every person gets one. Then I go the second round, each and every person, and I have to start where I have to go back to where I started so that I can get each and every person equal gift. And that's how the load balancing works. It automatically distributes traffic to multiple resources. Then it acts as a single point of contact into the autoscaling group. Now, if you see here, we have autoscaling group. So whenever autoscaling adds a new instance, that EC2 instance must be added into where it must be able to receive traffic. And therefore, when autoscaling adds a new instance, it goes straight to the load balancer to be able to start distributing, to receive traffic. Now, we talked about availability zones. And I said that a region can have 2 or more availability zones. Most of the regions have at least 3 availability zones. Load balancer is capable of sending traffic across multiple resources in different availability zones, not just one availability zone, in different availability zones. And this is where you talk about highly available. Because if one AZ is overwhelmed with traffic, then the load balancer will not take traffic there, will take it traffic to availability zone B. So with that, let's talk about elasticity. And I just talked about when there's low demand, we have autoscaling behind our scene that is adding more EC2 instances into our autoscaling group. And for that autoscaling group to start, for that EC2 that is added here to start receiving traffic, it must be within or behind a load balancer. So we have 2 on the left, 2 EC2 instances when there is no demand. But when the demand increases, we have 4. But then the all the EC2 instances, they are behind a load balancer, because we want to make sure that our traffic is distributed across multiple resources equally. Okay. Before I said any question, I think Nahashan are doing a great job down there answering all the questions. Thank you so much. So we talked about a couple of services, and one of it was compute. So we've talked about EC2 instance. And by the way, EC2 instance, these are virtual servers. Please keep that in mind. They are virtual servers. They are virtual machines. And since we have virtual machines, you hear people talking about serverless computing. And in serverless computing, people will say, okay, what is, to your own knowledge, we'll say serverless computing is that, or serverless means no servers. Yes, it means no servers. But then ask yourself, can your code run without CPU, without memory? So serverless means that you are running your code, but you are not the one. You see, before here, we were the ones who are deploying all these EC2 instances. Okay, so we are the one deploying these EC2 instances. You have to manage a couple of things. But when you start talking about Lambda is a serverless compute service, because it allows you to run your code without provisioning or managing the servers. So you are not provisioning or managing the EC2 instances. Someone else is doing that behind the scene. The only thing you need is your code, and the server and your resources or your application will run effectively. Now, the good thing with Lambda is you only pay for the time it runs, and you pay for the number of requests. So, what does that mean when I mean by compute time? So let's take for instance, Lambda. Before you go to the example, with the Lambda, it can only run, the maximum time is 15 minutes, and it can only use 10 gigabit of memory. In Lambda, 15 minutes is like when you press your WhatsApp button on your phone, it takes 15 minutes to open. That's how you can say it's that's Lambda, because Lambda runs in seconds. But then Lambda does not work on its own. It must be triggered. It must be invoked. We're going to see some of the services on that invokes Lambda and how we can work with Lambda. It's a very cool service, very automated. And if I give you an example, how Lambda can work is, we just concluded our general elections, and you can remember IEBC we are pushing all the forms from all the 46,000 into their portal. So we could have created a Lambda functions that goes in and checks that website or that public portal every time there's a new item that has been uploaded. It goes in, download that form, take all the results and put it into a database. That we can do automatically without any problems. It goes into the portal, look for the new file that has been uploaded, download it automatically, or sorry, not download it, checks on it, get all the information that we ask Lambda to pick and push it into a database. Nothing more. It just wait for files to be uploaded. That's a very good example when dealing with Lambda. So we are not using any server at all. We are using Lambda functions because we want to run our code without managing any server, because those were so many forms that were being uploaded. So we don't want to even download those forms. We want just to go in, check this information, put it into a database, and we can then provision that database. We're going to see a good example of how we can create such an infrastructure. So as I said earlier on, Lambda does not work on its own. You have your code. You want your code to go into AWS, so to IABC portal, gets the results of, let's say, the president, and then tallies it and put it into a database. Okay, so you upload your code and then you set the trigger. So the trigger can be either a storage. We're going to see storage in the next few seconds. Then it only runs whenever there's a new upload that has been done. Every time the IABC uploads a form, that's when Lambda function will run. And we only pay for the time that Lambda function is running, and it runs in seconds. I'll put that there. So we can use some storage to run our code. Now, what type of storage do AWS have? What type of storage do AWS have? We have three main categories of storage. First is Amazon Simple Storage Service, Amazon Elastic Block Storage or EBS volumes, and we have Amazon Elastic File System or EFS. So what is Simple Storage Service or S3? I know most of us have ever heard of S3. Now, S3 is an object level storage within AWS. With S3, you are not limited to the amount of data you can store. The only limit you have is the bigger the file size, which is 5 terabytes. A single file can only be 5 terabytes big, but in terms of storage, you do not have any limit. S3 is designed for 11 nines. There's so many nines here. You can see those nines. If you count them, there are 11 nines. Durability. What does that mean? It means chances of a file getting lost is 0.0, all those zeros. Okay. Now, S3 has different classes. And those different classes, remember, when you talk about benefits of using cloud is cost optimization. Okay. So how do we do cost optimization, or how do we reduce cost when dealing with storage? And once S3 has different classes, and each different class has its own benefits and the reason and the reasoning behind it, or the design for it. So we have for frequently accessed files, we talk about standard. For infrequently, we have standard IA and one zone IA. We're going to see those ones in a second. We talked about regions when we were discussing about global infrastructure. Now, an S3 is a service. S3 as a service is a global entity, meaning it is not tied up to a region. If I compare S3 with an EC2 instance, EC2 are tied up to a region. If you go to region A, you launch an EC2 in region A. You go to region B, that EC2 instance will not be there. But S3 is a global entity, meaning if you launch if you create an S3 entity, then you're going to find it in all the regions. What do I mean by an entity? S3 stores its data in buckets. Stores its data in bucket, and it supports various use cases. A good example is we can use for our a static website, okay, where you only have images, or people are just looking for your site. You can use it for the static website, or you can use it for your archival purposes, for storage purposes, through what we call versioning. And this comes to where you have multiple teams accessing the same bucket. People can either accidentally delete files, or overwrite some files with the latest or previous uploads. To avoid that, you can use versioning, where you can keep tracks of multiple resources or multiple files. But then this one here, you have to be very careful with it, because if your file is, let's say, 10 GB of files, if you add versioning to them and you upload them, that means, and you upload a newer version of the 10 GB, at the end of the day, you'll have at least 20 GB, because you have two versions of the files in the same bucket. So also to avoid accidental deletion, you can add what we call object locking, where you determine and close files or objects for a given period of time. So that is object level storage, and the example of object level storage is simple storage service. Then we have Amazon Block Store, or Amazon EBS volumes. So you can equate EBS volumes as the hard disks of your laptops or your desktops, because they are a block level storage, where it can be replicated. Now, that is the term. It can be replicated, but it cannot be accessed from multiple locations. So it can be replicated. You can copy from one region, from one AZ to the other, but it is not accessible from multiple availability zones. You can scale up and down. We have a couple of volume types. We have what we call general purpose and provisioned IOPS, which have different prices and different performance and different use cases. So, and we also have cold HDs and provisioned HDs, where those are the ones that you can use for cold HDs. They're basically used for with data warehousing. Okay, where this throughput is a requirement. Okay, so because we have 4 types, we have provisioned, general purpose. So we have general purpose, provisioned IOPS, and cold HDs. Now, with our EC2 instance, we have our server, but do we need a hard disk for us to install operating system? Yes, and this is where now Elastic Block Store comes in for both storage and booting. The 4 types of EBS volumes are general purpose, provisioned, throughput optimized HDs, and cold HDs. As I said earlier, that throughput HDs and cold HDs, they are basically used for data warehousing. Okay, but for general purpose, this one that offers general performance. But for provisioned IOPS, they are a bit expensive because of the input output per second of the throughput, and the throughput within which they offer. An example of an EBS volume is we can attach one EBS volume to a single instance. Okay, one EC2 instance, one volume can be attached to a single EC2 instance. But a single EC2 instance can have multiple EBS volumes. As I said earlier on, EC2 instance cannot spin or cannot span across multiple availability zones, and therefore we can only access our EBS volume within a single availability zone, and we can only have at least multiple volumes for a single EC2 instance. But what if we want to have multiple, a single access, a single storage, but that can span across multiple availability zones? And this is where now the EFS comes in, or Elastic File System comes in. Elastic File System is simple, scalable, fully managed file system. Now, when launching the EBS volume, you have to determine how much space you want. If you're in a free tier, I'm going to see those free tier in a later date, is that there's that free range that you can use for almost a year without any charge. I think it should be about either 20 or 33 GB. I'm not quite sure. When launching an EBS volume, you have to define how much space you want. And that EBS volume can only be accessed within a single with a single EC2 instance in a single AZ. But when we want to have a common file system where a fleet of EC2 instances can access as a common repo or a common storage, or even on your on-premise or data centers can access the same file storage, that's where the EFS comes in, because it is scalable, meaning it is elastic. Sorry, it is elastic. Elastic means that you do not define the storage. You don't define the storage. You only say, I want an EFS. As the time goes by, the more you add the data, the more it expands. So it scales on demand into petabytes without disrupting any application. So the more, because if you look at the way EBS works, if you compare to the EFS, is that for the EBS you have to do an extension. When you change the instance, when you add the volume, you have to go inside the server and add and extend that volume. But with the EFS, you don't do that. And as I said earlier on, with the EFS, we can access data within multiple availability zones. So it makes it easier to have a cost-effective file system, cost-effective in terms of storage, because instead of managing 20 EBS volumes, we only have one file system that we are looking at. It reduces our cost greatly when dealing with that. And 2, it offers a shared file storage. And this file storage can be, we are accessing the same storage from AWS at the same time from on-premise, if you're having a hybrid deployment. Okay, where we have applications running on your on-premise and other application running on AWS. They all access the same file system. And two is dynamic elasticity, as I mentioned earlier on. Then we have database. But before we go to database, can we have a 5-minute breather? Then we can assume that you can have a glass of water. Is that okay?
Thank you, Stephen. That's a good idea.
Yeah, thank you.
That's a good idea. Let's have a 5-minute break. As he said, please stretch, have a drink of water, and we'll see you back here in 5 minutes.
What is this cloud computing? Instead of having this physical machine with you here, you can create, or rather access most of these resources on demand access. And they use pay as you go model. So pay as you go means the more the resources you are accessing, that's the amount you'll be billed or you will be paying. Ideally, most companies currently, they are trying to leverage using cloud technologies to store the information. Most of the pictures you upload there, where are they being stored? That is now the power of cloud. We have Amazon, which now offer under AWS, which is Amazon Web Services. They offer cloud solutions. And then we have GCP. GCP is Google Cloud Platform. And then we have Microsoft Azure and many more. We partnered with Amazon, so we train most of their certifications program. Those certifications are, we have entry level or rather foundational, associate to professional level. So you can enroll into either of the certifications so that now you start your journey to the cloud. If you are a developer, it becomes much easier for you now to build your products on the cloud and make sure that they are easily available.
Okay. Let's continue. Awesome. Thank you. All right. So before we continue, something else, just a quick summary, because I'm just going through some of the things is that we've just talked about compute services. We just talked about EBS volumes. We talked about S3 and EFS. But remember, I said take EBS volumes as the actual hard disk, where you combine them into you associate it with your machine, and so that the machine can start up. Some people are used to running the application inside their laptops, meaning the application is running there and the database is running there. So what kind of what database options do we have on AWS? So in the next few minutes, we're going to talk about database options and what we can do with database and what are the options we have in terms of cost, in terms of types, in terms of the engines that we can use. AWS has three. We're going to talk about AWS has two main categories: relational databases and non-relational databases. In a relational database, we have a service called Amazon Relational Database Service, Amazon RDS. And in an relational database or NoSQL databases, we have Amazon DynamoDB. Then you ask yourself, how then do we migrate to AWS? Okay, now this is specifically the database. So we are going to look at database migration service, DMS, a service that you use to migrate your database from your laptop all the way to AWS without changing much. So we start off by talking about Amazon Relational Database. And Amazon RDS is a fully managed service. Let me explain what does the term fully managed service mean. Now, at one point in your life, you were living with your mom, and probably you are, let's say, 2 years old. Okay. So at that point, everything was being done for you. The only thing that you were to do was to make sure you eat. Okay. The only thing that you could do was eat. So the only thing that you are concerned is there food in the house? So whatever, if you don't have the roof, that was not your problem, or it's not your problem. Whether people are eating or what people will eat, that's not your problem. Whether clothes are being cleaned, that's not your problem. Your problem is there food? This is, I'm talking about a 2-year-old kid. Is there food? That's the only thing I want. So in a managed service, this is where we have there's only a bit of information, a bit of task that you take, you as the customer, and everything else you leave it to AWS to manage. So anytime you hear the word fully managed service, it means once you provision it, AWS will take care of it in terms of scaling, patching, security, encryption, backups. That will be done for you by AWS. So it tries, or Amazon RDS tries to remove and automate the time-consuming administrative tasks. For example, if you're doing a backup, you have to create what do you call it? You have to create a maintenance window, so that at some point at that point, services will be unavailable. At that point, you need to make sure you have a rollback plan. Okay, so that is sometimes some time-consuming task that I'm talking about. But when we talk about fully managed service, especially the RDS, the only thing you are concerned is the performance of your hard disk, or your RDS. How optimized is your database to accept new queries or whatever your database is doing. 2 is that, and 3 is that it's secure. As I said earlier on, is that it's encrypted both on transit and at rest, and it is compatible regardless of what which database engine you are using. Probably you're using MySQL, you're using Postgre, you're using MongoDB, you're using DynamoDB. It is sorry, not DynamoDB or MongoDB. You're using MySQL, or you're using Postgre, or you're using Oracle or Microsoft SQL Server. Those ones will be compatible with Amazon RDS. Sorry, for MongoDB and DynamoDB, those ones are not compatible with RDS because those ones are non-relational databases. My apologies. Then it's very easy to administer. I see most people uses something like Workbench to make sure that they are able to access the database. But at a security level, at a security perspective, you never put your database at or in public subnet, or it can be accessed publicly. That is not a best security practice. We're going to see why. I talked about different type of engines, and you say with the AWS it supports it's compatible with this type, or with all these engines. We have SQL Server, MySQL, Oracle, and Postgre, and MariaDB. Then we have something called Aurora, Amazon Aurora. Now, Amazon Aurora is a database that was built by AWS in cloud. it is compatible with PostgreSQL and MySQL. However, it is 5 times faster than the normal MySQL and 3 times faster than the normal PostgreSQL. When you use Amazon Aurora, it creates what we call read replicas, or it duplicates itself such that the database is highly available at any given point. 3 availability zones, and it creates 6 replicas automatically without you doing nothing. So once you create a cluster, Amazon Aurora cluster, database cluster, automatically it creates 6 replicas in different availability zones. But why does it do so? And how can we then use the other database engine to act the same? For us to act the same, then we need what we call multi-AZ deployment. In a multi-AZ deployment, you have 2 sets of databases. One is called the primary database. And in the primary database, this is where now everything is, everything goes in. Whether someone is requesting for a specific file, or someone is inserting or creating a user, inserting to the database. But then it has what we call a standby database. Now they run concurrently, and both data, the primary and the standby, they are synchronous, meaning whatever is in standby is actively in primary. In case the primary goes down, or in case the primary is not available, there's an issue with the primary, then the standby is automatically converted into primary without much downtime. But if you find that, because those are 2 databases that you're running at the same time, okay? In terms of higher availability, the 2 multi-AZ deployment creates what we call high availability. And for us to acquire high availability and to offload our database from huge queues, and probably they are read requests, then you can use what we call read replicas for read heavy databases. What does it do? You create read replicas to direct all the reads, or people are just saying, I want to see something. You're not registering, you're not adding anything, you're just viewing something. So all those requests will be directed to the read replicas. At some point, read replicas can be converted into primary. That would be the extreme, or not even extreme. That can be done because read replicas, they have a time lag. There's a time difference from the primary. So whenever there's someone create a new file or a new record in the primary database, it takes some time before it goes to the read replica. That's what we call replica lag. There's a time difference between the time that the record was entered and the time it appears at the read replica. So read replicas and primary DB, they are asynchronous. There's a time difference. So that's all about relational databases. And this is our databases that we store information in rows and columns. Create databases, we create tables. Those tables have a relationship with one field or the other. But then we have other databases that they are not relational. We call them no SQL database or non-relational database. The reason why is because the way data is stored, it's stored in key value pairs or in a key value document. Well, while in relational database, data is stored in rows and columns, but in the non-relational database, data is stored in key value pairs. An example of a non-relational database is DynamoDB. So DynamoDB has one advantage that makes it way, way powerful. First, it is a serverless database. If you can recall, when we are talking about compute, we say there is one compute resource. What was the name of that serverless compute that we talked about? So here I'm watching at the answers. So what was the name of the compute resources that we said it is serverless? What was the name? Let me see. What was the, how many people are getting that? Awesome. So we said that Lambda was the serverless compute. Thank you so much for those guys. Thank you. So we said that Lambda was a serverless compute service. Now, when I was talking about the IEBC portal and our past election, I said we can use Lambda for our compute. How then can we use Lambda with relational database? It can be done, but it can be more effective if we can use a serverless application, meaning we have a serverless compute and a serverless database. Okay, it will be more easier and more effective because DynamoDB offers a single-digit millisecond performance at scale. But this is the normal one. If you feel that that is not enough, you can add a service or a feature called DynamoDB Accelerator. When you add that DynamoDB Accelerator, you are going to get a single-digit microsecond response time to DynamoDB. So when can I use DynamoDB? I can use DynamoDB when I'm talking about serverless web application. For example, I've just given you an example of an IBC past election. We could have used that to make sure we are getting all information in real time. One of the most important concept of DynamoDB is gaming. And in gaming, because of the response time, okay, let's say you are an online gamer and you're using a normal database, and when you're fighting, someone's throw a punch. So it takes like a few seconds before the punch hits you, okay? But you need a high speed response time. That's where DynamoDB comes in, and Internet of Things and mobile backends comes into place. So we've talked about Amazon RDS and DynamoDB. So right now, most of a couple of organizations are trying to migrate or are trying to move to cloud. But then they have the challenge of, yes, I have the application, it's running well on AWS, but then how do I move the database to the cloud? So we have a service called Database Migration Service. And in the Database Migration Service, it helps you to quickly and securely migrate your database without without very less configuration. And apart from whatever this point that is here, one thing I want to mention here is, let's say back here, if I go back, I may, let's say our on-premise database here is MySQL, okay? But you want, when you migrate to AWS, you no longer want to start using MySQL. You want to, let's say, to use an SQL server or an Oracle DB. What happened to that instance? So at that point, we are going to use a service called Schema Conversion Tool. Schema Conversion Tool. Let me see if I can put it on the chat. Schema Conversion Tool, SCP. I'm not sure if I'm able to type. Yeah, I think I am. Schema Conversion Tool. Now, that tool will help you convert from one engine to the other on the other side. So the source can be MySQL, but the destination or the target can be a different engine. So with the DMS, it's seamless. It can be one-time migration, or it can be a continuous migration. So depending on how your applications are running, then that is your aim. So far, we've talked about databases. We've talked about EC2 instances. We talked about storage. But the question is, how are all these connected to each other? How are EC2 instances, how are they able to communicate with the database? Okay, how are we able to communicate between resources, between EC2 instance and a database? We're going to talk about networking on AWS and content delivery. And for that, the resources that we're going to look at today are VPC, Amazon Route 53. I'm not sure whether, do you say is Route 53 or Route 53? Is it Route 53 or Route 53? Now, this is where your schools come into play. So whether you went to polling station, group of school, academy, now this is where they come into play. Yeah. So you have to know, if you say Route 53 and then you go and check it is Route 53. Now you know where your school is, right? So now, depending on how you call it, it is Route 53. Then we have Direct Connect and Amazon CloudFront. Now, let me touch something about CloudFront. So, not CloudFront, Direct Connect. I think we are going to, okay, let me get it to that point. So I'm going to start off from the first one, Amazon Virtual Private Cloud, and then move towards the right. So virtual VPC or virtual private cloud, these are virtual networks that you can use to launch resources inside them. Call them virtual networks. Let's say in your organization, or even if at home, you have that small router at your home. That small router creates a network within your home, because every single device that you connect into that router is built within your network. Okay. So therefore, we want to create a virtual network on AWS. Instead of having that small router with you, then how do we create our network, such network on AWS? If you're coming from an organization that has huge networks, then you see that there are networks that are divided into locations. Let's say we have the HR network, we have the finance network, the IT network, development network, and so forth. So this is when we can now start saying, okay, so we have our network, and we start now subdividing our network into subnetworks. Now, these subnetworks are called subnets. Now, with the subnets, they then go and create what we call a defense in-depth within the virtual network. In the defense in-depth, this is where we have, sorry. This is where we have multiple layers of security within your network. Okay, the defense in depth, and we are going to see how defense in depth work on AWS, because security is one of the key aspects when dealing with when working with cloud computing, and everyone is paranoid of maybe I'll be hacked, maybe someone is trying to hack me. So how do you deal with such a situation, and how is security in AWS? So with the subnet and the defense in depth, we're going to see how security is catered for on AWS. But with the VPC, there is you don't have to know everything, because my slogan is, you may know a lot, but you cannot know everything. So always learn. If you don't know how to create a VPC, there's what we call the default VPC, which is fully configured, and you can use it as it is. on AWS. So whatever you do, once you log into AWS or create an account, never delete that default VPC, because other services are using that VPC. So if you find yourself that you've deleted that VPC, I would recommend that you can reach out to AWS through the support portal and say, hey, I deleted my VPC, I need it back, because some of the services may not work if you delete that default VPC. Now, VPCs, they are region-based, meaning one region can only have 5 VPCs, but that 5 VPCs does not mean you cannot have more. That we refer to that as soft limits. In a soft limit, you can always request for unlimited increase. So if you're having 5 VPC and you need more in one region, then you can always go back and request for a limit increase. So how does it look like? So a VPC, in a nutshell, this is what we've discussed today. We've talked about, let me see if I can start drawing. Hopefully, yes, I can start drawing. No, I cannot draw. So we've talked about EC2 instances. And let me start from the outer region. So there's that black lines called AWS. That is the AWS environment, or that's the AWS infrastructure. Then we have the regions. We say that a region is a geographically located, isolated location that has low latency and very connected to AWS global infrastructure. Then now we have VPC, where we said it can be, you can subdivide our VPC into subnets. Now those subnets can be private or public. Now, whatever you put on public is not that you want people to be accessed from the public domain, but something like databases, okay, or some of the sensitive data, you can put them into private subnet, where if they have to be accessed, then we are going to talk about how do you access them from your corporate data center or from your office? How do you access them privately into AWS private subnet? Another networking and content delivery service is Amazon Route 53. Now, Amazon Route 53 is a very highly scalable DNS web service. It has three main for a start. It has these three main functions. One, it translates the domain names into numeric IP address. For example, if you go and check what is the for those who are good in IT, if you do a DNS lookup at Zalego.com, you're going to see that Zalego.com is tied up into a specific IP address. So the work of the Route 53 is to translate, since the computer does not understand Zalego.com, so it has to get the number that is understandable. So the work of the Route 53 is to translate Zalego.com into an IP address, which is then will be transferred to us to the load balancer and straight to the EC2 instance. Now, using the Route 53, we are able to connect users to our infrastructure within AWS and on-premise. What do I mean by that? Remember, when you're talking about type of deployments, we talked about hybrid deployment. In a hybrid deployment, you can have a failover where Route 53, as I said, because I said Route 53, these are just a few of use cases. We can use Route 53 for failover, okay, to route traffic to healthy endpoints. That's what I was looking for. So what does that mean? That's what I'm able to ask as the failover. So in the failover, it monitors the health checks of your endpoints. Let's say if your endpoint is a load balancer, and a load balancer is monitoring an EC2 instance, and it finds that an EC2 instance is not healthy. It takes that information back to Route 53. And Route 53 then say if you're having a hybrid deployment, and let's say your EC2 instance is not healthy, then Route 53 will redirect traffic to somewhere to a healthy on endpoints. Or for example, you're having a hybrid deployment and your database is on your on-premise or your data center, and your application is at AWS. And you find that in one or the other, there's no electricity in your on-premise, and the database and the generator did not kick in at the right time, and the CP and the UPS data is off. So what happened? Then Route 53 will see that as the unhealthy endpoint. If it is unhealthy, then it routes traffic to where it is it's healthy. So we also with the Route 53, we can transfer DNS record names for existing record names. So that is called CNAMEs or conical names, where we have steve.com be transferred to, can be maybe created as stevo.com. It can be the same thing, then routes traffic to the same name. We can also create and register new domains. Let's say if you want to buy a new domain, let's say steve.com, then you can use Route 53 to buy new domains. And as I said, that it ensures high level of availability for multiple name servers. Now, that is Route 53. So what is the relationship between Route 53, load balancer, and an EC2 instance? So as I said earlier, let's say we have something called subdomain.example.com. So, and you are hitting an example of steve.com, for example. If you hit steve.com, it goes to the Route 53, and Route 53 will say, okay, so steve.com is, I will translate it to an IP address X. Then that IP address X will be routed to the load balancer. Now it's the work of the load balancer to tell us where that traffic is sent. So load balancer will then configure that that traffic, as we said earlier on. So, but how do we create a hybrid deployment? Because I said in this here, we say that it connects users' requests to infrastructure within and outside of AWS. So how then do we create a hybrid deployment? So an AWS Direct Connect is a cloud service solution that makes it easy to establish a dedicated network connection from your on-premise to AWS. It reduces the network cost, a partitioned connection to multiple virtual interfaces. Now, we all know VPNs, okay? And in VPNs, we can create a VPN to connect to our, maybe from your machine to the office network. But we can also create a VPN that connects from your network to AWS. Now that VPN is simple and you can do it on AWS. But then that one is dependent on the bandwidth that you have. If you're using 5 Mbps, you're going to get that 5 Mbps. If you're using 10 Mbps, you're going to get that 10 Mbps. So it is fluctuating. If you want to have a steady, low cost bandwidth, then direct connect will be the most cost effective connection. However, it is not a direct create that you can jump into the AWS console and start creating it. You require a third-party vendor that are authorized by AWS to offer direct connect. So part of it is security. Sorry, part of it is security, where it creates it is so secure, and you are guaranteed of the bandwidth because it can offer to 10 gigabits per second. So, and this one we can use it to create a hybrid deployment, because we want to have, it's because it's a dedicated private network, right? So it creates a connection between our on-premise to AWS easily, okay? But you have to go through a a vendor authorized by AWS to offer this direct connect. Now, when I was talking earlier on, when I was discussing about the global infrastructure, I said that in Kenya, we do not have a region, but we have an edge location. So what is the edge? And we said that edge location, we use it for caching of content to bring the content closer to our customers. If our customers are in Europe and we are working here in Kenya, so what we can do is that we can push our content closer to where they are in an edge location. But how will they be able to access that content, that cached content? Then we can use Amazon CloudFront to quickly deliver content to customer globally. So for us to use CloudFront, we require an edge location. We integrate seamlessly with other AWS services. For example, we can use CloudFront to send to a load balancer, to send traffic to the load balancer. Okay, we can use Route 53 to send traffic to CloudFront. However, you need to be very keen in terms of charges. If you can see there, we're saying that there's no charges when you're transferring data between origins, between AWS origins. What does the term origin mean? Origin can be, let's say you have a hybrid deployment and you want traffic to be routed from an S3 bucket to an EC2 instance. Then the transfer of that data will not be charged. So the EC2 instance or an S3 bucket or your corporate data center can be an origin. But then when you talk about AWS origins, then you're talking about something like Amazon S3 or an EC2 instance or a CloudFront. So with CloudFront, there's no minimum commitments. You only pay for what you use, and it has a wide range of use cases. So if it is a software distribution, people with Mac, there's a software that you can install and you can issue to students. They'll be downloading your updates from a single location. Then CloudFront works best with that. So you have video streaming and static asset caching. Static asset caching. This is why I said that you can have a single region providing such information. How it works is that, a good example is a figure like this. Now, in a figure like this, we have our content, an S3 bucket in South America, but our customers are in Europe. So it will be slow for a customer to access content in South America. So what we do, we cache that information into an edge location in Europe so that customer can access it from where they are. But what happens if content are not available in an edge location? Now, another level of security is that you do not allow clients to access directly from your origin or your S3 bucket. You can only allow CloudFront to pull your content from the origin to cache it. So that's another layer of security that you can put, that people do not access, because if you give people access to the original document, they may tamper with it. So once someone tampers with anything at the cache or at the edge location, it can always be replaced. So I'm not. Let me check whether there are any questions. Do you have any questions, Nahashan? Any questions that are coming along on the chat? Okay. So if there are no questions, let me ask my questions. Okay, because I'm seeing no questions that are coming through the chats. So let me now ask the questions. Okay. Awesome. So, which AWS service automatically distributes traffic across multiple resources and availability zones? Okay, so I'm seeing a couple of answers here. Yeah, I'm seeing a couple of answers. That's good. Awesome. Thank you so much. All right. So we talked about the load Amazon EC2 Elastic Load Balancer, so that automatically distributes traffic across multiple resources and availability zones. Is it true or false that Amazon EC2 instance is a service that provides highly scalable, high-performance container orchestration? Is it true or false? Container orchestration. Okay. Sorry. So what offers container orchestration is Elastic Container Service, which I think we are going to talk about it later on. I'm not sure why it's not on these slides, but I'm going to see about that. Okay. Which service is the best option to use if you need high performance block storage? Okay. Awesome. So we said that ABS, they are for block storage, while EC2 instances, they're not, these are server or compute services. Then we have S3 for object level storage. And another one is true or false. Amazon Elastic File System can only store data within a single availability zones. Is it true or false that we can store data only in a single AZ when using Amazon EFS? Awesome. So we said that the only storage that offers single location is EBS volume. But for the file system, it can have multiple availability zones, and therefore that statement is false. We get into database, and we ask that which AWS service is the best option to use if you need no SQL database that is serverless. Awesome. So we said that DynamoDB is a serverless, no SQL database or non-relational database. Another one is which database service support multiple database engines, including Amazon Aurora, MySQL, and PostgreSQL. Awesome. So we say that RDS is the one that offers relational databases, and some of the engine it supports or it's compatible with Amazon Aurora, MySQL, and PostgreSQL. Another one is which of the following AWS services is highly available and scalable DNS web service? Which of the following AWS service is a highly available and scalable DNS web service? Route 53. Awesome. Last, which AWS service is a fast content delivery network? Awesome. So we say that for content delivery, we need two services. We need Amazon CloudFront and edge locations where data is cached, but we use CloudFront for content delivery. So the most key point or the most takeaway here is we have a broad range of services and functionalities, but we cannot exhaust them as of this. If you need more information, you can come to Zalego and you're able to give you more information, and you can choose the cost that you want. But for now, we're going to stop there and invite Alex before we go for the next module to say a word or two as I took so that we, as Alex comes in, I'll say, can we take a break of a few minutes?
What is this cloud computing? Instead of having this physical machine with you here, you can create or rather access most of these resources on demand access, and they use pay as you go model. So pay as you go means the more the resources you are accessing, that's the amount you'll be billed or you will be paying. Ideally, most companies currently, they are trying to leverage using cloud technologies to store the information. Most of the pictures you upload there, where are they being stored? That is now the power of cloud. We have Amazon, which now offer under AWS, which is Amazon Web Services. They offer cloud solutions. And then we have GCP. GCP is Google Cloud Platform. And then we have Microsoft Azure and many more. We partnered with Amazon, so we train most of their certifications program. Those certifications are, we have entry level or rather foundational, associate to professional level. So you can enroll into either of the certifications so that now you start your journey to the cloud. If you are a developer, it becomes much easier for you now to build your products on the cloud and make sure that they are easily available.
Okay.
Welcome
So,
back. Yeah, Stephen, please take over.
Go ahead, thank you. So this is our last module, and our last module is more of security and compliance. As I said earlier on, that security tops the most concern of everyone. So we are going to look at the overview of the security, shared responsibility model, AWS security services, and compliance. But what is security? If I may ask, what is security? So I'm looking at the charts right now. I want you, anyone just to have a mention. What is security so that I can see? Okay, someone says protection of the organizational resources. So most of the things that we try to figure out in security is first, visibility, auditability, controllability, and agility. Who has access to what? Who need access to what? Who did what? And who is doing what? So with AWS, we have a model that is called shared responsibility model. Now, in a shared responsibility model, this is like a person who has rented an apartment. Remember, the landlord is not responsible for you locking your door, but he is responsible for locking the door at the main gate. Okay, so you have to understand what are my responsibility as a customer, and what are the AWS's responsibility. Now, we are going to look at some of these responsibility in a nutshell, but then this is a very deep, in-depth or deep topic that you're going to look for probably after this. Now, security or customers provide security in the cloud. They provide security in the cloud. Some of the security that we provide in the cloud is operating system, application, security groups. We didn't talk about security, but if you're going to come to enroll into one of the courses, we're going to have an in-depth of some of these security features that we talk about in AWS. Operating system, host-based firewalls, networking configuration, account management. So in a nutshell, you as a customer provide access, provides security of who has access to your account or to what within your account. But then the AWS provides security of the cloud. And when you talk about security of the cloud, we're talking about the physical infrastructure. The physical, because we cannot, all of us, go to South Africa to manage the security of that data center, or we cannot go to Europe to manage all those data centers. So the responsibility for AWS is to manage security of the underlying infrastructure. That is security of the cloud. So it can be the physical data center, hardware and software infrastructure, network infrastructure, virtualization infrastructure. It can be storage, database, anything to do with the physical item within AWS. That is security of the cloud and its responsibility of AWS. So what are some of these security services that we talk about when dealing with AWS? We have identity and access management. We're going to look at each and every one of these in depth. So we have identity and access management. We have detective controls, infrastructure protection, data protection, and compliance. So we start off by identity and access management. So in identity and access management, we talked about Amazon Cognito, where we offers identity management for your application, where users don't require you to create an account. They can use their Facebook, Twitter, or Instagram access to access your account. We also have AWS Directory Services. Directory Services, this is where we can have is a managed Microsoft Active Directory service. Then we have Identity and Access Management, or IAM, where it helps you to manage access, secure access to your AWS account. Then we have Amazon or AWS Secret Manager. And the Secret Manager, this is where you store all your passwords. For you to have access to that Secret Manager, you need some specific permissions for that. Then we have single sign-on. In a single sign-on, this is where you have, let's say you have your Facebook account, you have your Gmail account, you have your domain account, and then you have your AWS account. You want to make sure that instead of managing 4 different accounts, you're managing one account that has access to all the 4 accounts. So that's where single sign-on comes in. When you discuss about detective controls, we need to know how do we detect threats? How do you detect a malicious activity? We have Security Hub, Guard Duty, Inspector, and Mercy. Okay, all of them doing different services at any given point. Because if you look at Hub or AWS Security Hub, is a Unified Security and Compliance Center. AWS Guard Duty, it manages threat detection services. Inspector, this one it allows you to intelligently detect threats or manages application threats. Then we have Mercy, that allows you to discover, classify, and protect your data. That is the detective controls. Then we have infrastructure controls. We have AWS Shield that will shield us from DDoS attacks. Then we have application web firewall. Web firewall, instead of earlier on, I talked about defense in depth. So you can start from Route 53, then from Route 53, instead of now going to CloudFront, you can have WAF that protects any MySQL injection or any malicious activity by monitoring the network of your application. Then we have Firewall Manager, where it manages is a central place to manage our firewall rules. When we talk about data protection, we need to know when do we protect our data and how do we protect our data. For KMS or key management service, we're talking about encryption services, right? We having hardware key services, cloud HSM, right? Or managing the SSL certificates. We manage it with the certificate manager. So with the certificate manager, you can instead of allowing your server to terminate the SSL TSL certificate, you can allow the AWS load balancer or Elastic load balancer to terminate your SSL, offloading that task from the server to the load balancer, which is more secure. Then we have compliance. And compliance, we talk about the AWS artifact, okay? With the AWS artifact. I'll go a little bit deep on identity and access management and see, because this is where the first security when dealing with AWS starts. Because the first time you create an account, the account is called the root user. The root user is the person who logs in using an email and a password. And this is the person who creates an AWS account. So the person you log in using is called the root user. It is not advisable, or it is not the best practice to constantly or on a day-to-day activity you use the root user, or you start operating a database, for example, using the root user. It is not recommended. What is recommended is once you create, because the root user has access to everything and anything. They have access to anything and everything. But then it is advisable, or it's the best practice, to create another user. Now, that user, we're going to talk about who is that user and what they can do. So with IAM, it controls access to resources, manages users and groups, and also manages multi-factor authentication. Now, multi-factor authentication is another layer of security for your account. So back to the root user. So the root user has access to anything and everything. But since it's not advisable, you create a user, and that user we refer to them as IAM users. And IAM user is an identity, is an entity that represents a person or application that interact with AWS. When you create an IAM user, by default, they do not have any permission, and that we call implicit denial. When you start giving them permission, you start now doing what we call an explicit denial. So right now, when you create a user, by default, they don't have permission. That is an implicit denial. When you start now giving permissions, that is now explicit denial. When giving permissions, you use least privileges principle, where I only give permission to users when they needed for the resources that they require. So I don't have to create users and give them full access. I only create one user and I give full access is the administrator, because as I said, we don't use the root user. So we create a user and we give them administrative rights. Now, as much as they have administrative rights, doesn't mean that they have access to everything. They may have access to anything, but not everything. They may have access to anything, but not everything. So there are some of the things that an admin user can do, or there's some, because a root user can do anything and everything, but an admin user does not have access to do everything. But in an organization, for example, we are at least above 90 users. Right now, we've logged in this session. So if we are working in a corporate institution, and I have to create all these users, I have to know who is doing what. For example, this person need permission to database. They need permissions to Route 53. They need permission to VPC. They need permission to S3, and so forth. Do I have to go every single person in the entire 50 users? So what I can do is that I can group people into IAM groups. And instead of now issuing permission to a single person, I issue the permission to a single group. Whoever is in that group inherits the permissions of that specific group. So it makes it easier for me to manage users within a single group. Now, a user can be in multiple groups. Now that has to be you have to do that very carefully, because within AWS, we use what we call IAM policies, okay? Let me see if we have that. Okay. So we can have a person, for example, John belongs to a group called admins and a group called QA. Okay. Now, when we deal with AWS permissions, okay? When you deal with permissions, you need to be very careful, because John belongs to two groups, and groups called admins and group called QA. So how do we give permissions to these two groups? And please keep in mind that John belongs to group admins and QA. We give permissions by the use of what we call IAM policies. An IAM policy, or IAM, a policy, is a document that defines the permissions within AWS. A policy grants or denies permissions to AWS resources. As I said earlier, is you follow the least privileges principle. Now, let me go back to the use of policies. Now, a policy in AWS is a tricky one, because if we have two policies, one that denies, another one that allows. Let's say you have a policy that allows access to EC2 instance, another one that denies access to EC2 instance. That denies will always rule the one that is, it will overrule and allow. It will overrule and allow. That means if we have let's go back here. Let's go back here. Sorry, let's go back here for a second. Okay. So we have John, Sophia, Mateo, and John on two groups. Then if in QA, we say that in QA, they are denied access to EC2 instance. Okay. Remember, admins, they have access to anything, but not everything. With IAM policy, deny always overrules. Now, listen to this. If in QA, in a group called QA, the policy denies access to access to EC2 instance. And since we know that policy, a deny policy rules, then in this case, as much as John belongs to the admin group, will not have access to EC2 instance, because in group admins, he is allowed. But in the group of QA, he is not allowed. They are denied. They have an explicit deny. So meaning John, belonging to a group of admins, will not have access to EC2 instance because of an explicit deny in the QA group. So when issuing permissions to groups, or when someone belongs to one or two groups, you have to be very careful of the permissions that you're giving. If it's a deny, then the person will be denied access, even if he belongs to 10 groups, all of them allowing, because a deny always rules. Then we have an additional layer of security. We talked about MFA. It provides a layer of security, and it's at no cost. You see, most of the finance team usually use the token, the hardware that provides after every 5 seconds. It provides them with some keys. Then we have virtual devices. Virtual devices can be, an example would be the Google Authenticator or the Microsoft Authenticator that you can use for MFA. So I mentioned about earlier on about AWS Artifact. And I said that Artifact is a free service that provides on-demand access to security and compliance reports. So it's a self-service. So you log in, you go in, and you do. You don't need anyone else. But you can review, accept, manage, and agreement with AWS. So you can also get compliance report from third-party auditors. So third-party auditors can be, let's say, other organizations that are doing compliance with AWS. Some of these organizations can be like the FISMA from the ISO certification, Cross Security Alliance, and GXP, or any other organization that now AWS must comply. And these organizations, some of them are region-based. If you go to Europe, they have their own organization in which AWS must comply with them. Okay. When you go to the US, they have their own. When you go to Asia, they have their own. And these are the services, or these are the compliance organization AWS must comply with. With those short remarks, I would like us to, if you can join me, we do few questions with me. And this is about AWS shared responsibility. So what I want you to do is, I want you to tell me whether it's the responsibility of AWS or the customer. So if it is a customer, it will be grayed out. If the AWS, it will be an orange one. Okay. Configure the security group rules that determines which ports are open to the EC2 Linux instance. Whose responsibility is that? Whose responsibility is that? Is it AWS responsibility or it's customer's responsibility? I'm waiting. Okay, so I don't want to go back, but this is one of the security, one of the features of security in the cloud, because you want to know which port are open into your EC2 instance. Okay, so that is security in the cloud. That means it's the security of the customer. Now, the next one is prevent packet sniffing at hypervisor level. So whose responsibility is that? Whose responsibility is to preventing packet sniffing at the hypervisor level? Awesome, thank you so much. So we said that at the hypervisor level is security of the cloud. This is hypervisor level is the physical infrastructure. All right, the next one is patching. Patching the operating system with the latest security patches. Whose responsibility is that? Okay. So here, this is the operating system of the EC2 instance. So this is not, when you launch an EC2 instance, it's no longer the responsibility of AWS, because this is the operating system. So this you're managing your infrastructure. Shredding disks before they leave a data center. Whose responsibility is that? Whose responsibility is that? Shredding of disk drives before they leave a data center. Awesome. I see. I'm seeing some good answers. Thank you so much, ladies and gentlemen. So we said that is the responsibility of AWS, because these are the physical infrastructure. That is for the work done by AWS. So securing the internal network inside AWS data center. Awesome. So we say that it's the duty of the AWS to configure and secure the actual data center. Next one is installing camera system to monitor the physical data center. The physical data center, so anything to do with the physical infrastructure, that is AWS. Tumbling of the server-side encryption features for Amazon S3 buckets. So for encryption, server-side encryption for S3 buckets. So that is the work of the customer, because customer, they are responsible anything happening inside the buckets for them to make sure it's secure, it's encrypted. That is the work of the customer. So one more question is it true or false that within your AWS account, you must create all your IAM policies initially? So there I'm getting some mixed reactions. Okay, so you don't have to create all your IAM policies initially, because AWS has at least more than 600 policies that you can use, or you can come and create those IAM policies by yourself. So you can either use AWS's and or you can create your own. The most key takeaway to this slide is we have a very comprehensive and very flexible security services, and security is a responsibility that is shared between you, the customer, and AWS. So, and this can be considered the difference between security of the cloud, meaning the security of the data center, and security in the cloud, where we are talking about security of in cloud for the customer. And lastly, we talked about on-demand access to compliance reports. On another level, if you come to do solutions architect, or you come to do cloud practitioner essential, which is certifiable, then you're going to discuss more onto all this. So with no further ado, ladies and gentlemen, I really appreciate your time from the time we started up to this minute. Thank you so much for your time. I hope all the questions have been answered, but if not, I'll try to go through the question and answer them. For this minute, I'm handing it over back to Alex and the team so that we can continue with the rest of the program. Thank you so much.
Thank you. Thank you so much, Stephen. Thank you for that. It was very comprehensive and very detailed, and I think that you have won over a few of the attendees with the value of AWS as an organization, and as well as for their skills and for their careers. So thank you so much for that. And thank you so much to the attendees for taking your time to come and join us today. We know that these things are not easy to be a part of. We know a lot of you have got obligations and challenges and work, but we appreciate the fact that you've been able to spend 3 hours with us today. You have learned a lot. We have enjoyed being your hosts, and we've enjoyed engaging with you. And please, if you get a chance, if you're in Westlands, please visit us. Also, sign up for any courses that interest you. Ask questions. We'll be glad to answer any questions that you have. But I want to hand over just real briefly to excuse me, to our principal John. Just to give him a couple of moments to also thank you, and then to let him close this event, and then we can proceed from there. And then we will be sharing a registration form with you. So that should be in the chat, should be popping up in the chat any minute now. Please take a look at that as well. But for now, let me hand it over to John, and then John, please say a few words to the attendees, and thank you.
So thank you so much, Steve, for taking us through that session. I think it was quite an educative session. And again, as Alex iterated, we can't emphasize even more how AWS would be a beneficial course to each one of us who have attended. So for the form that is being shared, kindly make sure that you fill in your details. We'll be sharing the resources that were used after this. And remember, again, we are also issuing a certificate of participation. And most of all, I'd like to encourage you all to consider coming for at least one of them. At this point, for those who have not interacted with AWS before, cloud practitioner essentials, and also solutions architects at the point. And what we'll do for you will be able to guide you which to take depending on your interest and also where your interests are. So as we conclude, please visit our website. We'll share the link. The courses we have on offer. At Zalego in a building called the Van Plaza on Sway Road. That's just the shrine on Wayaki. You come from if you would like to get some guidance on You can also give a call or contact somebody on the website. You can email us to info@zalegoacademy.ac.ke. So I will look forward to having you on board. Also, just wanted to, if you fill in your details, you can also reach out just to understand or even give further information these trainings and opportunities that are coming up. One thing I'd like you to consider is that also ensure that our alumni, we try and get them into touching this internship and all the jobs if possible. You're not, you're already not. There's also the opportunity to switch careers and and so that I'd like to thank you for being in attendance. We hope that this is a relationship between you and the Zalego Academy. Thank you so much. So
Thank you. Thank you, John. Thank you so much. You were breaking up a bit there, but if there's what you've said, we'll go ahead and add it on the chat for people. Just let them know what the website is. Let them know our location. You can visit. You can sign up. I've also added the registration form for those that are interested, and you will be contacted soon after for that. Once again, we really want to thank the attendees. We appreciate your time. We appreciate the fact that you are willing to spend 3 hours of your Friday with us, of your Friday afternoon, particularly with us. So we are very, very thankful for that. We want to thank the team that is behind this over at Zalego. It was really the work of a lot of people. We want to thank that team, all of you who have been a part of the build up to this AWS Discovery Day. We are very, very thankful and we appreciate your time. And once again, please, if you're in Westlands, please visit us at our location. You can also visit us on our website. You can send us emails. You can ask us questions. There will be people that will respond to you. I promise you that. And we look forward to having you as students. Again, we understand the need to upskill. We understand the need to improve your career path and your career value. So we are very thankful for all of that. If anybody has any questions, we have about 14 minutes left. If you want to ask a question on here, anything that Stephen can answer for you, I will leave that floor open for you to ask that question. And please, don't be shy. Just say what's on your mind. Stephen is very available. As you saw, he knows his material very well, and he can answer any of those questions for you. So please, if anyone has any questions, please go ahead. You can raise your hand. You can just unmute yourself and you can say something short and brief, and Stephen will try and answer that for you.
I see, Peter, you have your hand raised up. You have any question? Peter, I've allowed you to talk. You can unmute yourself, please. Also, I have a hand raised from Raphael. You can unmute yourself, Raphael and Peter Keru, and Raphael Kimari. You can unmute yourself. You can ask your question, please.
Hello, am I audible?
Yes, you are, sir.
The question was in regards to the link that was sent on the chat. So, is the link for another registration or is it for the academy? Because the email I'm getting, it's a confirmation of a registration.
Okay, that's a very good question. Beth, would you take that, please?
Okay,
Alex?
thank you.
Go ahead, Beth.
Yes, thank you. This one serves two purposes. It's basically for those people who have gone through this class. So we will also be using that list to also just create certificates. Yeah.
Okay, thank you. Understood. And kindly, where is the location of the and where are you located along Waiakio?
Stephen, please take this one. Okay. We are located around Divan Plaza, just on the Westland stage.
Yeah. Okay.
Yeah, Divan Plaza, Westland stage. In case of anything, we've been sending communications out. So in case you're lost, you can just call that number, the number that we've provided in the SMSs or the SMS communication that we've been sending. So in case you're lost, just call that number and we'll direct you to our place. It's very straightforward. The location.
Thank you.
Okay, karibu. Wesley also has his hand raised. Okay. Back to you, Stephen.
Hello. Hello.
Yeah, go ahead, Wesley.
Yeah, so I wanted to inquire, is it possible to send the whole recording since some of us did late?
I don't think we can hear you, Wesley.
I wanted to inquire, is it possible to send the whole recording of the lesson since some of us joined late?
Yes, I believe it is possible. Yeah.
Yeah, kindly do.
Okay, we will do that. Yeah. Back to you, Stephen, Alex, or John.
Yeah, so we are waiting for if anyone have a question or they need some more clarification. So I'm not quite sure whether I saw a question. I'm not sure whether it was answered. Someone asking about does it mean that I don't remember who was that. I saw it, but since there was a couple of guys, I'm just trying to look for it. Oh, here we go. So it was from Brenda. Gitaushi says, does this mean that if it's denied, if it is denied, that means for specific group, the user will not be able to read only and cannot access or interact? Yes. If Brenda, you are in, it means once you get denied, you cannot get any access. The only message you'll get is you are not authorized to access this resource. So I hope I've answered your question, Brenda. So once it is denied, it's denied. It's called an explicit deny. Do you have any other question? No, I don't think I have any other question. All right, Beth. I guess as of now, we can now call the day off because from the time we allocated, it's exactly 5. As we said, that's when we'll have our remarks. And I really appreciate your time, everyone who have joined. So thank you so much and enjoy your day. So Rafael, your hand went down. Okay, anyways, so thank you so much for your time. If the registration is done, yes, Rafael? Let me allow you to unmute. Oh, sorry. Your hands up again, Raphael.
Yeah. So I was asking on the courses.
Mm-hmm.
So is like, does it? How do I phrase the question? So can you take the administrator or the administrator course before taking the essentials one, or is it a must you go from the essential to the associate to the developer and then to the administrator?
No. You can go directly to sysops. You call it a system administrators. So the reason why we say it's good is because it creates more of like a base, right? It's like you have a baseline where to start. So when you're going to administrator, though you're going to start everything from scratch, but then you'll not be it will not be something so new to you. So you'll be now going into details of it. So it will not be a new item for you. So you will not have like an FYI about it. So I guess we are good if there's no any other question. So if you have more questions, you can drop an email or so someone says that there's a question above, but I'm not able to see it. Let me see. Okay. Oh, so this is Joseph, right? So let me unmute you, Joseph. This is Joseph Ombo. Sorry, just give me a second, Joseph. Oh, there you go. Yes, Joseph, you can unmute yourself now.
It is,
Yes, you can now unmute yourself.
he cannot speak.
So someone is asking how much is the developer's fee. I am in the office. Hold on, let me look for those questions. Sajid. Okay. So Joseph, I can't see your question. I cannot speak since I'm in the office. Can one do a course for solutions architects? Yes, we are offering that too. So you can also do that. Right. So let me maybe explain it in a nutshell. In terms of yes, let me actually explain that. So we have two modes. You can do either you can come in class or you can be online. So you can be online based on specific timelines. So that is I think John and the other team members can provide that information later on. But in a nutshell, you can do either online or especially now that you mentioned that you're in the office, you can do an online one or you can do an on class. Okay. On class, so the in class one, it's on a specific timelines, and it's for me. I usually prefer the in class one because there's a lot of practical sessions. You can ask a direct question whether the time is off, but either way, everything can work out as because nowadays everything is on virtual. So yes, we have two modes now. In terms of certifications, so how do I choose the right certification? So it depends on what's your path. If you're a system administrator, I will not suggest you go for solutions architect. So the best way is to go for system administrator course. If you're a developer, you go for the developers. But what if I'm a security, I'm a cybersecurity personnel, or I am a data analytics or analysis? So how do I choose, or how do I know which path to choose? So those paths are dependent, and most of the courses are dependent with the solutions architect, because the solutions architect goes in depth and goes one by one. It goes one by one services that you're supposed to cover in all the others. So with the solutions architect, you're able to cover most of the services that you need to with AWS. So as you go, let's say you're coming from cybersecurity. So in cybersecurity, you do solutions architect, then you do security as a specialty, all right? Or you're doing data analytics or machine learning. So you do solutions architect, because in the solutions architect, it covers most of the services that you need to progress to any other course. That's why solution architect is one of the most recommended course for most of other, especially when you're doing a specialty. I hope I've answered your question, Joseph. So how much is Riddhi says how much is for DevOps course? Okay. Now you need to understand there's a difference between developer as a certificate and a DevOps. Okay, because DevOps is more into automation, while the developer is using set of specific skills, services on AWS, and how you can now use your developing, how you can develop your application on AWS and use the necessary tools. Thank you so much, Donald. I appreciate your time. Thank you. You're most welcome. You can come to Divan Plaza, 6th floor. You're able to get more information. Thank you so much for your time.
What is this cloud computing? Instead of having this physical machine with you here, you can create, or rather access most of these resources on demand access, and they use pay-as-you-go model. So pay-as-you-go means the more the resources you are accessing, that's the amount you'll be billed or you will be paying. Ideally, most companies currently, they are trying to leverage using cloud technologies to store the information. Most of the pictures you upload there, where are they being stored? That is now the power of cloud. We have Amazon, which now offer under AWS, which is Amazon Web Services, they offer cloud solutions. And then we have GCP. GCP is Google Cloud Platform. And then we have Microsoft Azure and many more. We partnered with Amazon, so we train most of their certifications program. Those certifications are, we have entry level or rather foundational, associate to professional level. So you can enroll into either of the certifications so that now you start your journey to the cloud. If you are a developer, it becomes much easier for you now to build your products on the cloud and make sure that they are easily available.